doing in the last lesson, well, we did this thing called Venn diagrams, and we focused on the additive identity, the OR identity. Now today, the identity that's going to be beneath the surface of the tree diagram is this identity. And this is the identity for independent events. So just give me a thumbs up if you have seen or heard of this identity before. I just want to get a quick feel. Now, the way we normally use this is each branch of a tree can be multiplied. Okay, so some people have heard of it, some people haven't. So the way that this generally works is if, for example, we had a situation like, let's say a coin flip. So flipping a coin, and then we had rolling a dice. So this is called a compound event. The probability of the two options are heads and tails, okay? And for the second event, the options are 1, 2, 3, 4, 5, 6, and it's going to be the same over here. 1, 2, 3. I'm just doing this as a rough one now. I know it's not very neat. Okay, so the way a tree diagram works is the first thing it does is it tries to show you like how many different outcomes there are. So I want to ask you, in the event that I'm talking about, the event A is the result of tossing a coin, and event B is going to be rolling a dice. How many different possible outcomes are there if you flip a coin or roll a dice? So remember, you've got two things there. It's a compound event, and the two events are independent of each other. So when you flip a coin and you roll a dice, the result of each of those things is not going to be affected by each other. So I want to suggest that there are actually 12 possible outcomes. So look at the 12 branches of my tree. So 1, that would be heads 1. This would be heads and then throwing a 2. That would be heads 3, heads 4, heads 5, and so on. Now you can imagine I could do this 12 times. So there are actually 12 possible outcomes for this little experiment that I've made up, which is basically tossing a coin or rolling a dice. Now, what this identity helps us do, because these two events of tossing a coin and rolling a dice are independent, we can multiply along each of the branches. So, but to do that, we need probabilities. So if you toss a coin, what is the probability of getting heads? If you could put that in the chat, what's the probability of getting heads if you toss a coin just by itself? Okay, so it's just going to be 1 out of 2. And the probability of tails is also just going to be 1 out of 2. And if you add up these two, you're going to get 1 because it makes sense because there's only 2 possibilities. What's the probability of getting a 1 on a dice? And it's just going to be 1 over 6, right? What is the probability of getting a 2 on a dice? It's also just going to be 1 out of 6. And you can just keep going with this idea. So each of these branches is going to be 1 out of 6, 1 out of 6. And you can imagine doing that for every branch. So if I ask you the question, what is the probability of getting so let's say it like this, what's the probability of getting heads on the first part of the event and throwing a 3 on the dice? What we do is we say, well, what's the probability of getting heads? It's just going to be a half. So this part over here. And what's the probability of throwing a 3? Well, that is just going to be 1 over 6. And so using this identity, you can see how we just go, what's the probability of A times the probability of B? And so the answer would be 1 over 12. So there's a 1 in 12 chance. And that also makes intuitive sense because how many options are there? There's 12 possible branches. How many branches are there that satisfy this question that I've asked? There's only one branch. So it's 1 out of 12. So we use this identity by multiplying the branches of the tree diagram. And if, for example, I'd say to you, what is the probability of getting a head and a 3 or a 6? So say, for example, I changed the question, then another branch would have been involved. If I said to you, I want to know what the probability of getting heads and a 3 or heads and a 6 is, then what happens is you have 2 branches, and what you would need to do is you would need to add each of the branches. So that second question I asked, your probability wouldn't just be 1 over 12. Because you've got a second branch, that second branch would also be 1 over 12, and you'd add them together, which would give you 2 out of 12. So I've maybe got a little bit too much into detail now. It'll be easier if I show you in a question, but just give me a thumbs up if you understand the basic ideas that I was explaining. Thumbs down if you feel a bit lost. Just want a quick little kind of sanity check, I guess. Okay. It's a mixture. It's a mixture. So let's get going with a let's do this question. Okay, so I want you to start by trying to draw a tree diagram to show you the 2 options. Or in fact, I'll even help you. There's 2 dice. So dice 1 and dice 2. And in this question, use a tree diagram to find the probability that one number is even and one number is odd. So you're interested in knowing what is the probability of getting an even number on the roll of the dice? What's the probability of getting an odd? But then you have a second dice, which you're also interested in knowing about, whether it's even or odd. I want you to try and write in the probabilities for each branch and then try and answer this question using some of the thinking that I've showed you so far. So what do you think is going to be written in these spaces? And what do you think, what do you need to do to get at the answer of this question? So if we just focused on the even, what's the probability of getting an even number when you roll a dice? You could say 3 out of 6, or you could say a half. I think that, a half because, 3 of the numbers are evens and 6 of them are in total. So I think that each of these 2 branches is going to be a half. Now, throwing 2 dice, those are independent events. They don't affect each other. And so we shouldn't have any differences when we're writing these probabilities. The probabilities should stay the same. It should still be a half and a half and a half and a half. So now the question is, let's try and answer this question. Use a tree diagram to find the probability that one number is even and the other number is odd. So how many of these branches are going to be favorable for the question you're asking? Well, I know that that branch is one possible answer. And so I need to work out the probability of what that happening is. But there's also a second one, which looks like this. And I'll have to add those together at the end. So my first one's probability is just going to be a half times a half, which is a quarter. So that was the even, odd one, the probability of odd even is going to be a half times a half, which is a quarter. And since I've got two of them there, I have to add these together. So we should get 2/4 or a half. And so the correct answer is a half. It's C. So I want to pause for a second, ask, are there any questions or comments about that in terms of the process? I know not everybody is comfortable yet, and so please do feel free to ask a question or raise your hand. We're just getting going for tonight. What are the major stages we do? The one is we ask, what are the different things that make up the events? In this case, it was dice 1 and dice 2. And we ask ourselves, what are the different options that are possible when you throw 2 dice? And we have 4 different branches on our tree, and we have written in the probability for each of those branches. And then because we had multiple branches that we were favorable, we added them together. But if you think about it logically, only 2 of the 4 paths are taken, which means that there's a 2 in 4 chance it would make sense logically as well. Loretta, did that help my explanation there? So, well, let me go on to this example doesn't have enough variation. So let's go on to this next question, which is a bit more wordy, but we're going to take a lot longer to go through it. So we are given a situation where we are talking about 2 types of decisions in this question. So let's read through, take a moment, take 30 seconds to just read through this. And once you've read through it, say done in the chat. So I want to give you a bit more time because I'm aware that it takes time to process. So 30 seconds, read the question, and then say done in the chat when you've read it. All you have to do is read it. Okay, so just put done in the chat when you've read the question properly. And now I want to ask you, what is this question about selecting? So when I look at this question, you have to select things. What are the 2 things you're going to be selecting? What are the 2 objects that it's no longer going to be coins and dice. What is the main object you're selecting? Okay, so Dawn, I agree with you. It's shoes and socks. So I want you to draw a tree diagram where you have to choose shoes and then socks. Now, you don't have to do it. You could do socks and then shoes, but the question seemed to go in that order. So why, let's say you have to make these choices. I want you to first draw your tree diagram, no numbers yet, just draw your tree diagram. And once you've done that, I want you to just say tree diagram in the chat. So I know you've done the tree diagram. You don't have to put numbers yet. I just want the lines, the number of lines that you need. Do you understand what I mean? So I'm asking you to just draw the shape with lines. And then we'll put probabilities on those lines afterwards. And we're trying to understand the number of possible combinations of shoes and socks. That's where we're trying to get to. We're trying to get to the question asks us about the probability of choosing a certain type of combination, but we need to first understand, how do we even visualize this combination? So we have it feels to me like for shoes, we only have 2 choices. But for socks, we have red, brown, black. So how would we represent that? Well, I would have my first choice would show those choices, and my second choice would show my other 3 options, which are BR, BL, and red. Okay. Now, you can see my 2 choices, and at the moment, it looks like there's 6 possible outcomes, but not all of these outcomes are going to be the same because there's a different amount of things involved. So I want you to just take a moment now, and I want you to think about how many different types of shoes are there. Well, there's 2 black and 3 brown. So in terms of the total for shoes, you're dealing with 5 possibles. When you deal with socks, you're dealing with 3 red. Actually, 3 red, 4 brown, and 6. So that would be 11. And I see some of you may be asking, why have I put red at the bottom? You don't have to put red like I did. You could have actually put red at the very beginning. Because that comes up first. So why change it? So red, brown, and what was the last one? Black. Okay, now I want you to try and write in the probability of each of these events. So I'm going to give you a minute now, and I'll give you the hint. The very first branch, black, there are 2 pairs of black shoes, and there's 5 in total. So this is going to be 2 out of 5. I want you to try and figure out what these other branches are. And then once you've done it, just type probability in the chat. So you're trying to find out what each of these branches is going to be. How did I do this again? It's oh my gosh. 13. Yes. How did I do that again? Sheetless. Okay, 13. Well done. Thanks for spotting that. So I think that's going to be 3 out of 5. And what are these ones going to be? That's what I want you guys to think about. So this is going to be 3 out of 13. Okay, so Ayanda, what I'm doing with the second, so if you think about the 2 decisions we're trying to make, you can think of this as sort of like event A and event B in terms of the original thing. There's only 5 pairs of shoes, okay? So 2 of them are black, so the probability of choosing a black pair of shoes is 2 out of 5, and the probability of choosing brown shoes is 3 out of 5. When I get to the socks, they're no longer, there are actually 13 possible options. 3 of them are red, so that's why the probability of choosing red is 3 out of 13. For brown, it's 4 out of 13. And for black, it's 6 out of 13. And these branches are going to be the same for the second one. So now we have to decide, Okay, we haven't even answered the question yet. All we're trying to do is draw the tree diagram. So can I quickly have a question from the class, or do you understand how I'm drawing the tree diagram? Thumbs up if you understand how I drew the tree diagram. Thumbs down if you don't understand how I did the tree diagram. That's a quick little, I haven't answered the question. I just want to know if you see how I'm constructing this. That's the main thing. And we're going to do more of these. It takes practice. Okay, it's a bit of a mixture. Okay. So for now, all I've done is I've considered two events. The one is choosing your shoes. The other one is choosing your socks. And all I did was each branch shows a combination that's possible. So the very first one shows me choosing black shoes and red socks. That's the combination represented by the yellow line. Okay. Now, I don't know what the probability of that is yet because it's a compound event, but I could work it out. However, we could also say, what's the probability of getting black shoes and then black socks, which would be that event over there. So that's each of the paths along the tree represents a possible outcome. If you want to know the probability of that outcome, you multiply along the branches. Now, in this question, it says, what is the probability that he chooses shoes and socks of the same color? So I want you to think to yourself, which branches of the tree will satisfy this probability question? And the branches that I see, it would be this branch over here, black and black, or this branch over here, brown and brown. Now, in order to know the probability of getting both of these, or essentially, or either of them, is you're going to need to multiply. So for the first one, this branch, the probability is going to be 2/5 times 6/13. So that's for this branch over here, it's going to be 3/5, not 4, times by 4/13. And now what I need to do is I add, because both these branches are possible, are favorable outcomes, I need to add these together. And if I add them together, I'll get my final answer. So see if you can lock in your vote now. Which one do you get? So for this one, I get 12/65, and I'm going to add it to 12/65, which is going to give me 24/65. Okay, and Paul, let's go to you, your question. Hi, Paul.
So why are we adding the numbers, the fractions?
Okay, so if you think about, if I said to you, what is the probability of getting black shoes on your first choice and black socks on your second choice, I would only have to do one of them. But because the question said, what is the probability that he chooses shoes and socks of the same color, there are multiple branches that satisfy that question. So basically, it's because of the question. Because the question is saying, when are they the same? Now, there's no way we could have red and red because there was no possibility for red shoes. But because there's two branches, each of them is possible. And so both of those branches would be a favorable outcome for the question. So that's why I have to add them together. All of these different probabilities, if I added them together, they would give 1. The same way 2/5 and 3/5 gives you 1. All of these guys over here would give you 1. And the same with the final total. Okay. But the main thing that's, okay, brilliant and Paul, fantastic. Okay, now, that was a bit tricky. Are there any other questions before? I think we're going to take a break fairly shortly because I know that that was hard work. Are there any other questions from the class you want me to clarify? Like maybe I should adapt the question a little bit before, since we've done all this hard work. How about I say to you, what is the probability? I want to know the probability of getting brown shoes and red socks. Calculate the probability for me of that. What is the probability of drawing brown shoes and red socks for this particular question? So which branch of the tree am I looking at now? Brown shoes and red socks. It's just going to be, now, is it possible for another of the branches to work? No, I only see one branch. And so what I'm going to do is I'm going to go 3/5 times 3/5 times 3/13, which is going to be 9/65. Okay. What if I said to you, what is the probability of just getting a selection with red socks? What is the probability of getting a selection with just with red socks that has red socks in it? What would the answer to that be? Now think about that carefully, because I'm changing the question. You're going to choose shoes and socks, but what's the probability of getting an outcome where you have red socks? It's not just 3/13. Careful, careful. Oh, okay. I meant it in a different way. So I meant in saying, what's the probability? You have to choose shoes and socks. I want to know what's the probability that your final choice ends up with red socks in the mix. Not just, I actually wrote this, so let me say it like this. The probability of brown and red, or brown, black and red. That's what I meant to say. Do you understand how I've changed the question slightly? So in this question, what I'm asking about is basically, if I'm choosing shoes and socks, and I want to know what's the probability of having red socks, the only two branches that are going to be relevant for me are going to be this branch over here and that branch over there. So what am I going to do to get the probability of having red socks as part of the final thing? It's just going to be 2/5 times 3/13 plus 3/5 times 3/13, which is going to be 2/5, which is going to be 15/65. So I can see that there's still quite a few variety of answers coming in. So I think maybe I've extended this question a little bit too far. So don't stress too much. But basically, all I wanted to show you was I wanted to know the two branches that had red socks in their branch. I wanted to add those two together. And that's what I did to get 15/65. All right, our brains have been worked hard. I tried to remix something for you there. Let us turn on our cameras and let's stretch it out. So Lebo, if you could help me by identifying those students who are showing us their best stretch. I'm going to also have a stretch, and let's give our brains a bit of a break.
Come on, guys, please join in. Turn on your cameras.
Well, maybe happy is a strong word, but let's see those relieved faces that you're having a bit of a break.
Yes, let's see your lovely faces. Shout out to Pegelo.
Oh. Shake it out.
Shout out to Shisana. Yes, guys. Don't be shy.
There we go. Can't tell
Shout
you
out to Lisedi. Shout out to Tsofato. Yes, guys. Shout out to Ayanda.
Kevin, your body will thank you. You know it's true. You know it's true. Kevin, I want to see you stretching. Let's see you. You're not having load shedding today. Come on.
Yeah, I can't have load shedding every day.
I want to see Kevin's stretch. I'm super interested to see. Come on, Kevin. Oh, all right. Doesn't that feel good? Okay, let's us go to the brain break. And here is the brain break for today. You go to the doctor because you're ill. He prescribes you with 3 pills and tells you to take them every half hour. How long do the pills last you? Okay. What do you guys think? Think about it, ladies and gentlemen. So you take your first pill and you take them, you wait 30 minutes and you take your next pill. And then you wait 30 minutes and you take your next pill. Seems you have used up all your 3 pills. How long did it take you? What do you guys think? Oh, I see the answers coming through now. It is indeed 1 hour. Yes. Watch out, brain breaks can be tricky, ladies and gentlemen. I really do go and find you something a little bit special, or at least I try to. So I hope you enjoyed that. You can use it out in your friends tomorrow. Okay, let's go. Okay, so I just want to know, are there any questions or comments so far? Because I know this takes a bit of time to get used to. And so, yeah, please do feel free. The good thing is I'm live here, so I can answer your questions. Otherwise, we're going to go on to a next question. But, yeah, please do feel free to raise your hand or ask a question if you need to. All right, so here is the situation. And this is called drawing and replacing. Now, I want to ask you this question. If I have a bunch of marbles in a bag and I take one out, I write down what I got and I put it back, and then I draw again. Does the first draw affect the second draw in any way? So I just want to ask that question before we start. So you've got your bag of marbles and I put my hand inside and I draw a marble and I write down what I get and then I put it back in again. Will the second draw be affected by the first one in any way? Okay, and the answer is no, because you replaced it. So we can say that the first draw and the second draw are independent of each other. So when we ask the question, we're doing 2 draws, but we're replacing, we can use a tree diagram to represent this and to help us understand basically the different probabilities. So let's try and do this. We've got a bag contains 6 blue, 5 red, and 9 white. It's drawn and replaced, and then you draw a second marble. So basically, your tree diagram is going to have 2 selections of marbles, like marble 1 and marble 2. I want you to try and draw the tree diagram that you get from this, and it may have 2 or it may have 3 branches. And I want you to try and put the probabilities on each of these branches to show you basically the story of choosing these two marbles. Okay, off you go, but I would love a question along the way from a student if you're unsure. My one little hint is my first marble would have 3 choices. And the 3 choices would be blue, red, and white. Now, can you finish the rest of the tree diagram with the probabilities and the second level? And when you're done, just say done. I want to know from you in the chat, what are A, B, and C going to be if A, B, and C are just the probabilities for each of these branches? So I want to know, what are the probabilities for each of these branches? A, B, and C are the letters I'm using to ask you that question. And sorry, it's just this first part. It's not the whole branch. It's just this part of the branch. So for A, what's A going to be? What's B going to be? So A is going to be 6 out of 20. Yep, I agree. What's the red one going to be? It's going to be 5 out of 20. And this one is going to be 9 out of 20. Now, the thing about this is these are independent events. Nothing changes for the next selection. So it's still going to be 6 out of 20, 5 out of 20, 9 out of 20. And each of these is going to be that again. Going a little bit quickly here. But I think you understand the thinking, right? So your second choice is still going to have the same possibility of getting a blue and red and white. Now, I want to know, using this wonderful diagram you've created, you've done that already, use it to determine the probability that both marbles are white. So what is the probability that both marbles are white? Find the branch that you think is working and ask yourself, how would you calculate the probability of that branch? Bearing in mind that there are so which branch is relevant? I think it's just going to be this one down here, which means the probability of white is just going to be 9 over 20 times 9 over 20. Again, because these are independent events, remember from the beginning of the lesson, the probability of A and B, so the probability of white and white, is the same as the probability of A times the probability of B when the events are independent. And so that's why I can just go 9 over 20 times 9 over 20, because it's the A and B are the same event in this case. So what do we get for that? 9 over 20, 9 over 20, that's going to be 81 over 400, or in decimal, it's going to be 0.2025, or in percentage, 20.25%. Okay, now I'm going to change the question because we've done all the working and now I want to see your thinking. what is the probability that you get red in either of the two marbles? So that's my question. What is the probability you draw the marbles in the same way? What's the probability that you get a red marble on either of the that you get a red marble on your choice that you make? So this is a little bit, in fact, you know what, I'm going to modify it. It's going to take too long. Sorry, guys. What's the probability that, scrap that question because it's going to take, there's too many branches that have red. Let me change it. What is the probability of getting the same color marble? So let me rather change it to that. What is the probability of getting the same color for both marbles when you draw two? So that's my new question. What is the probability of getting the same color for both marbles when drawing it from this bag? Okay, so I've changed the question because the original remix was not going to end in a happy ending. This is a more appropriate. So think about which branches end with the same color and how would I add those all up? So this would represent a possibility with the same color. So would that, and so would that. So now to calculate my probability, and this is what's good about when you get used to this, is you actually know there's going to be three pieces to this. There's the top one, which is that, plus you're going to get that, plus each of those options would end us with a favorable outcome of the same color. This would end up being blue, blue. This would be red, red. And this would be white, white. But all of those would be considered a favorable outcome. So that's why we have to add them up. And if we add all those up, what should we get? So I get 142 out of 400, which if you simplify will give you 71 over 200, or if you write it as a decimal, it would be 0.355 or 35.5% chance. Okay, let's just do a quick reality check. Thumbs up if you feel like you're sort of following along. Thumbs down if you're still feeling a bit lost. Remember, we're doing 2 lessons on this and we're still getting going, but just want to lay the groundwork today. Okay, awesome. Okay, let's do one more question for today. Or at least let's just try this one. So here is the full question, and you're going to fly completely solo by yourself now. A bag contains 12 red balls and 5 blue balls. A ball is drawn at random and then replaced, and another ball is drawn. What's the probability that both balls are red? Off you go. Get me an answer for that. I'm going to get some water while. I believe in you. You can do it. so I'm guessing 17 is going to be an important number, right? So if you think about it, your chances of getting, this is actually relatively a bit easier than the last one because you have red and blue, red, blue, blue. And this, the only branch I'm really interested in is going to be the red branch. And so this is going to be 12 out of 17. And this is 12 out of 17. Now, in this particular situation, because they only wanted to know about the probability of red, I'm only going to need that one, which would be 12 over 17 times 12 over 17. Let me pull up the answers and you can have a quick look. So did you get, this is the big answer, did you get 144 over 289? That should be your final answer. So it's going to be which equals 144 over 289. Yeah. You know what you've done? Should be okay. You've done so well. Thumbs up if you can squeeze in one more. Thumbs down if you're like, I'm done for the day. Let me know if you, let's do a quick vote. We've got a bit of time and you've been on fire. So, you know, who am I to stand in the way of progress? You know, I mean, I don't want to leave my people unhappy. This cannot happen.
They are
okay.
flying through this.
All right. Let's do this old exam question then. Let me just get rid of some of this stuff over here. I'll move that down. We've still got time. Okay, so you've got the following question. I want you to start by trying to draw the tree diagram for the situation. So let's try and do 9.1 first. And I'm going to let you fly solo here. The only question I'll guide, well, yeah, let you fly solo. Let's do this. And just say done when you've done 9.1. Okay, so let's look at these different options. So bag A contains 3 pink and 2 yellow. Oh, wait, so there's only going to be 2 branches. So I'm getting ahead of things there. And what we should have is we should have pink and yellow. And this one should have pink, and yellow, but the branches are going to have different things on. So bag A and bag B, this is just going to be a half and a half because they're both equally likely. So it says in the question, equally likely bag A or bag B. And so that's why it's 50-50 or half-half. Now, when we get to the other bits, we should have for bag A, for pink, it's 3 out of 5. And here it's going to be 2 out of 5 for yellow. For bag B, it is going to be 5 out of 9. And over here, it is going to be 4 out of 9. Okay, now, how much time have we got left? Okay, I'm going to leave out 9.2 for now. Just give me a thumbs up if you understand my drawing for my tree diagram. Now, there's something else I actually haven't done. The question says, write down all the outcomes. I haven't actually written down, indicate the probability for each branch and write down the outcomes. If they say write down the outcomes actually here would be AP, AY, BP, BY. And so these are the possible outcomes that we can have. There's 4 possible outcomes. However, they're not all the same. Okay, now it says, what is the probability that a pink ball will be chosen? Okay, and it's for 3 marks. Now, they're asking you have, basically a pink ball will be chosen. So let's just go out, finish with that question, and then we'll call it a day for today. So Ayanda, the reason it's a half is that they're both equally likely. There's 2 options and so what is the probability that a pink ball will be chosen? We're just doing 9.3. That's what I want us to just think about. So you can get a pink ball going this route or going that route. Sorry, no, I'm just making things up. So you can get a pink ball in bag A, or you can get a pink ball in bag B. Those are the 2. So there's 2 branches that satisfy that, but now you have to work out the probabilities for me. So this one's probability is going to be a half times 3 over 5. And this one's probability is going to be a half times 5 over 9. But we have to add them together. And so what are we going to get in total? So let me put that into my calculator. Times that. My calculator is not working for some reason. So I can see a lot of you. Let me do my other one. .5 times 0.5 times 0.6. With 0.3. Well, that's actually obvious. And then this is just going to be 5 over 18. So and I get 26 over 45. So you should get, final answer, 26 out of 45, which I see a lot of you in the chat have got. All right, everyone. So I've just added together these 2 things to get the 26 out of 45. Well done, everyone.